last thing that we have to do is solve natural logs and exponential equations. We've yet to solve an equation. Okay, we've yet to solve an equation. So here are the steps. Anytime you're solving something, I don't know if you remember Algebra 2 where you solved radical equations, but you have to get the radical by itself first. Or if you're solving an exponential equation, you have to get the exponential piece by itself first. So these are no different. Like if you look at number 1 down there, the exponential part is this portion. We have to isolate that before we can do anything, so you have to sometimes move things left and right. So first step is to isolate the expression. Then we either take the natural log of both sides, that's one tactic, or you convert to exponential. I'm not going to put that. Okay? So if it's an exponential form, then you're going to do this. If it's an exponential form, you're going to do this. If it's in logarithm form, you're going to do that. I know that's small. The little blue word says exponential, and this little blue word says log. Bless you. You're saving those for these videos, huh? Then to finish up, we're going to use our properties to simplify. And then we're going to solve. Okay? So basically all you need to know is you have to get the expression by itself. If it's an exponential, you're going to use ln. If it's a logarithm, you're going to change it to exponential. And we'll finish class with an example of each. Okay? Number 10, we need to isolate the expression. So it's actually going to be 10 to the x plus 5 equals 68. This would be a pain. Yeah, you can kind of plug and chug in your calculator. I remember I used to do this in high school and just keep guessing for x until I got it to equal 68. Or you can just do this. You can take the natural log of this side, and then you can take the natural log of this side. Now here's what that does for us. Now that it's in logarithm form, we can use the power rule. What can we do with that x plus 5? Where can it move? What does the power rule say you can do with an exponent? It can move down front. So actually the way this is written now is x plus 5 equals the natural log of 10, or sorry, times natural log of 10 equals the natural log of 68. And now could you see how we could solve for x a little easier? Divide by what? Natural log of 10, and then do what? Subtract 5. It kind of turns into a manageable equation. So we divide by natural log of 10 on both sides. And so we're going to have x equals whatever natural log of 68 divided by natural log of 10 is, which obviously you're going to use your calculator, minus 5. There's your answer. This is the only way to really solve an equation that has the x and the exponent. So this is just the method that you'll use anytime you need to solve an equation with an x as the exponent. You've got to use logs to do it. Okay? It's like when you're doing harder things in Algebra 2, there's only one way to solve that, right? We gotta square both sides. Well, now we know how do we deal with exponents. You gotta use logs. Okay? And then this is all calculator. So look at example 2. Is the exponential equation isolated? Yeah. Sure. So then what's step 2? Natural log of both sides. And this is really nice because whenever you have ln of e, what happens? The ln of e just kind of cancels out and you're just left with the exponent. Okay? I should have done the natural log of both sides, sorry. So if you see an exponential equation, let's just take the natural log of both sides and it'll work. X is then going to equal whatever natural log of 14 minus 1 divided by 2 is. Okay? You with me on that one? Does that one make sense? I mean, logs cancel exponentials. But here's the last one. What if it's written in log? Okay, what if it's written like this? Which there is a couple in your homework like this. If you leave here today and you have this sentence kind of in your mind, then I'll be happy. To solve exponential equations, you have to use logarithms, but to solve logarithms like this, you have to convert it to exponential. That's how they work together. So how can we rewrite this as exponential? Remember what's sitting in this box right here? So what is it? There we go. There we go. And that's done then at that point. Because x is just going to equal what? Yeah. So as long as you remember to convert it, and then this can be done in your calculator as well, the little e button. As long as you remember to solve logs, use exponential, to solve exponentials, use logs, then you'll be good on this homework assignment. Okay? So for those who are in 6th period, the homework for this is 5.4. Numbers, well, you see it there on the module. I can't remember exactly what numbers it is. Just go look, though, because you'll tell me we didn't know. 5.4, 1 through 13, all. So for you guys, too, there's your homework due Monday. I won't see you again until Monday. Senior skip day. So you guys take it easy.